In the past, businesses recorded information on paper and stored it in files and cabinets. Imagine a company keeping records of sales data, inventory data, or employees' data this way. Over time, the data grows, and it becomes difficult for businesses to not only store the information, but retrieving relevant information also becomes a challenge. Today, we use something called a database. Think of it like a super organized digital filing cabinet, but instead of paper, it holds information in the form of tables. Each table holds a specific type of data. For example, you might have a table for customers, another for sales, or one for employees. Each table organizes data using rows and columns, just like a spreadsheet. Each row represents a single record like one customer or one sales transaction, and each column holds a specific type of information, for example, a customer's name or age. Now, here is the cool part. These tables don't work alone. They are linked together logically with something called relationships. To connect tables together, we use something called primary and foreign keys. Let's first understand a primary key. A primary key is like a unique ID card that helps the database identify each row within a table without any confusion. For example, in a customer table, we have a customer that gets a unique ID. Every customer gets a unique ID. For example, customer ID 001 only belongs to Alex, who's 25 years old. That ID 001 is the primary key, so no other customer can have it. The same idea applies to the sales table. Each transaction gets its own ID, like 0101, which identifies a specific sale, the one made on July 12th by customer 002. So, what's the rule here? A primary key must always be unique. So, no duplicates, no blanks. It's how a database keeps everything organized, just like every person has a unique passport number. So, now you might be wondering how we know which customer made each sale, right? In other words, how tables are linked together. That's where the foreign key comes in. In the sales table, there's a column called customer ID. That ID isn't just a number, it's a reference. It points back to the customer table where each customer has a unique ID, their primary key, right? So when the sales table says customer ID equals 002, the database knows this sale was made by the customer with ID 002. This is how we connect data between two tables. Even though they are stored separately, the foreign key creates a link so we can combine information when we need it. Databases that store information in this way are called relational database, and SQL is used to interact with relational database. Now that we have all this data stored in our database in neatly organized tables, how do we actually work with it? How do we ask questions, filter records, or pull insights from the data? And that's where SQL comes in. SQL stands for Structured Query Language, and it's the standard language used to communicate with the relational databases. Think of SQL as a way of talking to the database. Using SQL, you can read, update, or delete data from the database. You can also join the data based on the relationships of the tables, which makes it a really powerful language to retrieve insights from the business data. So, how do we actually talk to the database and get the information we need? We use something called a SQL statement, and it's basically a command we give to the database. A SQL statement is made up of keywords like select or from, etc., and identifiers, which are the things like table names or column names. Suppose we want to see a list of all customers, their names, and ID. Remember, our customer table contains two records in it, Alex and Sam. We'd write a statement like select customer ID, comma, name from customers, and then end it with a semicolon. Here's what each part means. Select tells the database what columns we want to see. From tells it which table we want the data to get pulled out from. And the semicolon at the end just marks the end of the command. You can skip it in many tools, but it's a good practice to include it. When we run this query, the database returns just the customer ID and name columns, exactly what we ask for. You'll notice the age column isn't included, and that's because we didn't ask for it. It's like saying to the database, hey, Mr. Database, show me just the customer ID and name from customer table. And that's exactly what it does. Now, let's say you only want to see customers who are older than 25. In that case, we can add something called a where clause to the SQL statement. The where clause or a where keyword lets us filter the data based on a condition like age, name, city, or anything else in the table. Now, coming back to our question, in order to answer it, our new statement would look like this. Select customer ID, comma, name from customer where age is greater than 25. This tells the database, show me only the customers whose age is greater than 25. And just like that, the database filters out anyone who doesn't meet the criteria. For example, if Alex is 25 years old, his record won't be included because we are looking for people older than 25. That's the power of a where clause. It helps us narrow down exactly the data we need. So, to wrap things up, we have talked about how data is stored in relational database, how tables are connected using keys, and how SQL helps us communicate with the data. If you found this helpful, give it a thumbs up and drop a comment with the next topic you want me to cover. Thank you for listening.